going to present an animation project called Matrix, Basic Matrix Operation. First, we are going to talk about basic matrix operation, addition, subtraction, and multiplication. So what is a matrix? Matrix is a way of categorizing numbers into rows and columns so that it takes a little less space, which we don't have to say what we are talking about. Be it a sophomore, junior, senior, boys, girls, however we're categorizing it. And we have a dimension of a matrix, which we say rows times by a column. Rows go from left to right and column goes up to down. Next, we are going to talk about addition and subtraction in matrices. In addition and subtraction matrices, each one of these numbers corresponds to a specific, like we mentioned before, be it a sophomore, male or something. We always have to add or subtract the corresponding part. Top left with a top left, top right with a top right. Just add or subtract the corresponding part together. It is really quite simple. Note, the dimension must be identical in order to have corresponding part to add or subtract. Here are some examples. That multiplication matrices. Multiplication matrices are divided into two, which they multiply with a scalar and with a conformable. In scalar multiplication, it is almost the same as basic multiplication. N represents the scalar and ABCD is the element. Simply multiply the scalar with each of the elements to get the answer. Next, conformable matrix. A conformable matrix is a method which can be applied when two matrices can be multiplied. To calculate it, you need to multiply the row of the first matrix with the column of the second matrix. You will get the product as shown in the animation. The same exact method of multiplication can be applied to the following conformable matrix. Matrix transpose. Matrix transpose is a method where each matrix column is converted into a row. Each column of the first matrix changes to row when converted into inverse matrix. The inverse matrix is a method where question is required to be changed back to a matrix form. There are a few steps to take note. Step 1. Matrix form. The first step is to take out the numerical element to change it into the first matrix. Then the alphabetical element will become the second matrix. And lastly, the third matrix will become the last part of the equation. The second step of inverse matrix is to determine A. Determine A is a method which element within a matrix is multiplied. Using matrix A as example, the next step is to add the first two columns of the matrix A into the equation, making it as fifth dimension. Then, to get the equation, you need to multiply the first upper left column to the third lower right. Do the same with the second and third column. The next step is to do the same, but this time we are going to multiply it from upper right to lower left. Do the same with the fourth and fifth column, the product of the first three multiplication minus with the last three multiplication. The third step, minor. Take out the first matrix from the equation and label each of the element. Then, for each of the element, you need to close the row and column accordingly. The element that are visible is the minor of the element. Here are examples for getting A. Next, the minor A is later multiplied using the same method as determine A. Use the same method with the remaining element. The result of each of the minor is then put together into a matrix form. The fourth step is cofactor. For cofactor, each of the element in the minor matrix is multiplied with the cofactor to get a new result. Fifth step, adjoint. Adjoint is the transpose of the cofactor of inverse matrix is 1 over 1a times by adjoint. Firstly, settle a calculation for the fraction. The answer is then multiplied with each of the element in the matrix. After that, the product is then multiplied with matrix C. Lastly, the answer of the final product needs to be written in 1 times 3 dimension.